Hello, folks. And so again, this still should be class period 7, and we're gonna. This is the second of these videos that you're going to look at. I wanted you to do two of these interludes that the book is calling for this particular lecture. And so we're going to look at. We're kind of jumping around a little bit. I realize that. So we looked at interlude A on the first video. This should be interlude C for this video. And again, it's a short video. It's a short little section, but it is super critical. And hopefully for most of you, it is review. We're going to be looking at the rock cycle. And again, by review, I'm saying I hope a lot of you pick this up in middle school or even high school and know a little bit about what the rock cycle is. And so hopefully, again, this will just be review, and you can kind of do it quickly, and we'll go into a little bit more detail probably than you did in middle school or high school. But this is kind of where rocks come from and how rocks are recycled. So we're going to look at the rock cycle. Let me get to the section here. There we go. So we're on interlude C in your book. Again, we're jumping around a little bit. So this is page 261. And so let's look at the rock cycle. What we know the three different types, right? And I'm going to go right to this picture here. We know the three different types of rock. We just talked about them in the last lecture. And they are igneous rock, sedimentary rock, and metamorphic rock. So the three different types, as we can see in the rock cycle, are sort of interrelated. In other words, an igneous rock can become a sedimentary rock, or a sedimentary rock can become a metamorphic rock. Metamorphic rocks can become sedimentary rocks, and sedimentary rocks can become igneous rocks. So it's a cycle in that, you know, it's a circle. There's not technically a beginning, although sometimes we start with igneous rocks because they are kind of where rocks are made from liquid magma in the mantle. But technically, again, one can become the other, so there's not really technically a beginning. So let's look at the cycle here, just sort of in relationship to each other. So let's start with igneous rocks, since we like to think of them as sort of the beginning, and your book sort of points that out down there in the bottom left-hand corner. Where igneous rocks can be made and destroyed in the mantle. So igneous rocks, as we know, are made from heating of molten material in the mantle, and then by some means, usually volcanic, these rocks come to the surface and don't necessarily have to come to the surface, as we will learn, but get close enough to the surface, or at least away from enough heat, that they will freeze. And by freeze, again, we don't mean they're cold. We simply mean that they have gone from a liquid state to a solid state, and that's freezing. So freezing may feel cold to us, but a rock that's just come out of a volcano, I wouldn't suggest that you pick it up with your bare hands. So let's look at igneous rock. Let's see how does an igneous rock become a sedimentary rock? Well, sedimentary rocks are formed by particles. By sediments. And so if an igneous rock were taken apart by erosion, transported and deposited somewhere else, it could technically become a sedimentary rock. What about metamorphic rocks? How could an igneous rock become a metamorphic rock? Well, by definition, metamorphic rocks are rocks that have changed due to increased pressure and temperature. Now, you might say, well, an igneous rock had a lot of temperature, didn't it? It was liquid, but we're talking about temperatures that will make rocks not necessarily melt, but simply become what we call plastic. And what I like to think of in terms of plastic is, if you can imagine a wax candle kind of left out in the sun, it's kind of flexible, not plastic like what they make watches out of these days, or pretty much everything else, not the noun plastic, but the verb plastic. To be pliable, to be flexible. And so that's what, so an igneous rock could become a metamorphic rock. What about a sedimentary rock? How could that become an igneous rock? Well, it could be an igneous rock through melting, right? And how do we melt rocks? Well, now that we look at the Now that we look at plate tectonics, we know that some crustal rocks can get pushed down into the mantle and can get remelted. And so it's possible that a sedimentary rock could be pushed into the mantle, remelted, and reformed as an igneous rock. How could a sedimentary rock become metamorphic? Again, same process. Sedimentary rocks could be built layer upon layer upon layer, and eventually so many layers that the bottom layers now have so much pressure, and that pressure creates heat, that these rocks can get changed into metamorphic rocks. And then metamorphic rocks, of course, can become sedimentary rocks from the same process, and igneous rocks by heating and melting. So this is the rock cycle. It goes in all different directions, and rocks that are on the Earth now probably or definitely were not here when the Earth was formed. These rocks, if the Earth was formed about 4.6 billion years ago, there are no rocks on this planet that are 4.6 billion years old. There are some that are very old, some in the billions, as we will see. But there are no rocks that are the same age as the Earth, simply because the rocks have been changed. They have been remelted and turned back into an igneous rock. And so there are no rocks on the Earth that are as old as the Earth itself. It's kind of strange when you stop and think about it. So anyway, let's look at some pieces here. Look at the case study here for the rock cycle and how that formed, and rates of transfer. Basically, how long does this take? Well, some things can be very quick, can't they? Volcanoes can spew out molten lava, and that lava can cool in just a day or so and make a new rock. So that's pretty quick. Others of these transformations can take hundreds of millions of years, and as this little story here talking about the Appalachian Mountains, which is very interesting, they can take billions of years. And so I tell the story in one of the grapevines that I travel over the Appalachian Mountains quite often to go to my parents' house in Tennessee, and on the top of the mountain are metamorphic rocks, which should not be on the top of a mountain. They should be at the bottom of a mountain. And I ask you to think about that in that grapevine, and we'll talk about that in more detail later. But here you can see some of the processes. Now, the process has everything to do with plate tectonics. In other words, before there were plate tectonics, there really wasn't a rock cycle, at least in theory, because we didn't know how these things could change or move. Now that we have a theory about how this happens, and lots of evidence to prove that it is true, then we can see how these rocks can change and mold. But really, it's all about plate tectonics. And you can imagine that if you lived on a planet where there were no plate tectonics, in other words, a planet like Mars, where there is no molten mantle, there is no solid core on Mars that's spinning, creating a magnetic field. It's basically just a big rock in space now. Then the rock cycle has stopped. There is no rock cycle. Wherever it stopped, whenever it stopped, it's kind of like musical chairs. Wherever you were at that time when the music stopped, that's where you are. You don't move anymore. You don't change anymore. So that's one of the reasons Mars is so fascinating, because Mars literally is frozen in time. And so we like to look at the rocks on Mars because it tells us quite a bit about what's happening here. Again, frozen in time. So again, read this section on what drives the rock cycle. And again, it's all about plate tectonics, plate interactions. It's if you want to look at gravity, even in terms of making sedimentary rocks. So these are the forces that if we did not have them, if we did not have an atmosphere, we wouldn't have plate tectonics, because we need weathering to create sediments, to create sedimentary rock. Your book talks a lot about other kinds of cycles. So cycles are very important, and always keep that in mind when you're looking at a big system, that these systems, nature in and of itself is a cycle. There's nothing new in nature. Everything has happened before, maybe in a different place, maybe at a different time, but cycles happen all the time. One thing will always become something else, and that's just the way nature works. Again, here are these big pictures that are really helpful, showing you how plate tectonics forms, reforms, destroys rocks, and make sure you look at that and have that in your notes.